All right, so let's spend a few moments talking about this idea of a random sample versus a simple random sample. So at first blush, these two words are going to sound very similar, these two ideas. Only difference being that one is talking about of a simple random sample. And unfortunately, I'm not so sure that just by calling it a simple random sample that tells you anything important. So here's one thing that's going to help us kind of think about it. We're going to work through an example, but essentially a simple random sample is the idea that when you take all samples of a particular size from a population, that each one of those samples has the same chance of being selected. So imagine that we have maybe 200 students. If I could mark each one of these indicating that we have a student, and I won't do 200 of them, but a simple random sample says that the likelihood of my selecting that group or that group or that group, if I'm just selecting a sample size of 3, like each group of 3 has the same chance of being selected. So for any one of these, right, it's going to be a different set of individuals, but each one of those has the exact same chance of being selected. So that's from a population of, say, that we have big N. It's a population of size 200, and if I sample one group of size 3, I get some individuals in my set. But if I sample another group of 3 individuals, those 3 individuals have just as likely the same chance of being selected. Now, why is that important? With a simple random sample, it means that this one sample here really looks, let's say that this is the sample here, that one sample, if it looks or has the same probability or chance of any of these other samples being selected, then we can make inferences. We can say, okay, yeah, here's a sample of the population, and that this sample is likely to represent the population. So we can work with that and make inferences from that. So let's kind of look into that a little bit, dig into it a bit deeper. So let's say that you have a class of size 200. So maybe your freshman class or your sophomore class. So that's the entire population of all, not the class, but the male students. So the male student population, there are 200. And what I want to do is sample from that group of 200, and I want to sample maybe a sample size. Let's say that we work with the sample size let's go with 10. So my question in here is, how can we select from that 200 10 individuals? And of those 10 individuals, that any one group is just as likely to have been pulled out from any other as any other group. So how can we do that? So here's a kind of a simple exercise that helps us gives us some more additional insight on random samples. So let's say that we have, in fact, male names here. So I have this website that I'm looking at called randomlists.com. And random lists allows you to select a number of different data sets of different sizes and allows for duplicates or not. So I'm working with randomlists.com, and let's pretend that this is your class of maybe your sophomore class, and these are all of the men in all of the boys in this case, all of the young men who are in this class. So we have 1 through 200. So typically and commonly in statistics, we may want to know something like what is the average or the mean height, right? What is the population? What is the population's mean height? So, and for whatever reason, because some of these individuals are maybe taking doing classes online, some are on vacation, some live in different parts of the town, not everyone's at school together at any given time. So for a number of reasons, it may be difficult to access all 200. So we want to get a subset, right? So if we were lucky enough to get all 200, then we might be able to go in and figure out that the mean height of those, let's say that it might be 5 feet and let's say 5 feet 9 inches. So what is that, 69 inches? So the average height for the population in truth might be, let's assume it's 69 inches. Well, if we can't get to the average height, then we're going to have to work with the sample. And we're going to have to get a statistic. So in this case, if we were able to get to a population, then we would be able to take that population and get its parameter. So this is the mean. And if we're able to get to the population, we have what's called a parameter, referenced in an earlier discussion. So since we can't get to the entire population, what we have is a sample, and so X bar is called a statistic. And it's not likely to be exactly 69 inches, but we may take those 10 and we may come up with, let's say 68.2 inches plus or minus 1.1. So 68.2 inches is what we'd come up with, and this idea of plus or minus 1.1 would be a bit of a fudge factor if we were trying to guess the population. So let's kind of hold off on that. But for this sample that we have, turns out that we can get 68.2 inches. And we can use that to some extent to make a statement about the population value. It's not exactly the same, but it hopefully is somewhat close. If we've done our sample, our simple random sample correctly. So in this case, let's say that we have our 200. How in the world can we sample 10 and make sure that any group of 10 is just as likely as any other group? There is a function in your calculator. So let's go to the catalog here. Let's say I go to second, catalog, and I type, let's say I type R. R takes me down to random integers. And so random integers is a tool that we can use to generate numbers, say between 1 and 200. And then let's say that I want 5. I think we said 10. So our sample, we're going to grab 10 of those individuals. And the way that we're going to do this, notice that if you look at this, there's a number 68, 241, and so forth. Looks like I should have my 10 numbers here. What I'm going to do is store that value into list 1 so that it might be easier to look at it there. So let's go over into list, and actually stats edit is what I want, stat edit, and we have our list 1. Let me go ahead and make sure this doesn't cause any confusion, get rid of list 2, but over here in list 1, those are those numbers that I just generated. So I have these students then. I have student number 68, Liam. I have student number 200, Alonzo, student number 41, and that would be the individual that's not showing up here. That would be Dakota, and so forth. I have generated a random sample of size 10 from those 200. So that is a simple random sample. Now, if I quit this, and if I were to go back and generate another simple random sample, this is a different group, the 2, the 110, the 172. So let me go ahead and store that into list 2. So that's going to be shift list 2. And go into stats edit, and I have these guys over here, and there could be some overlap between the two, but this random sample, this simple random sample of 10 is just as likely to have been selected as the first random sample. So that's the basic idea of a simple random sample. This kind of captures this idea that all samples of a given size, and in this case our sample size was 10, has the same chance of being collected. And we're going to use that random sample in this case to, in this case we wanted to get the average height. So as we go forward, the one thing I think that's helpful for thinking about simple random samples is simple random samples have a particular sample size associated with it. So tie those two together and it's going to make it pretty easy. So a simple random sample, more often than not in our class, is a subset of a particular size from a larger population, and more importantly, and generally what we're going to do is take that simple random sample that we pull, come up with a statistic, and use that statistic to try to say something about the population value. So we're going to say that the population value is actually, we have some level of confidence that the population value is within here, right? Let's make this 1.2. That is 68.2 plus or minus 1.2. So 68.2 plus or minus 1.2, and let's take away 1. That would make it 67, 1.2, and add, let's go ahead and add 1.2. That's going to take us up to 69.4. So this is the kind of the common exercise. We're going to say that with 95% or some particular confidence level that the population value is within that interval. And the larger our sample size is, the smaller the unknown is, the smaller that fudge factor would be. So this type of inferencing, when it comes to, is pretty common, whether it comes to votes or trying to make a statement about a population as a whole. And so it requires a sample of a particular size, generating an interval where the population value is contained with some level of confidence. So that's why we talk about simple random samples. It kind of puts us into this framework of allowing us to think about the population value.